Contamination is defined as any matter which alters or interferes with an activity, process or product. Sometimes three groups of contaminants which are categorized as solids, particles and fibers, microorganisms, such as bacteria and fungi, either alone or attracted to the particles, and third, liquids or films, which include chemicals, oils and greases. These contaminants are dispersed by products sensitive to contamination by viable organisms are a separate form of hazard. Healthy people are normally host to millions of microorganisms, many of which live on our skin or which we disperse from our body cavities, especially from our mouth when we speak, cough or sneeze. They can, however, be dangerous to people who are weakened by ill particles. Over 90% of them are invisible to the naked eye, which means that only particles over 40 micrometers in size are visible. Particles are a hazard when they settle onto surfaces, which they do as a result of two forces, gravity and electrostatic attraction. The effect of gravity on a particle is a matter of its size and the distance between it and the surface. Molecular attraction in contact, so that a sub-micron-size particle, a minute grain of sand, will have a much higher proportion of its molecules in contact with the surface and will create a very much stronger bond per unit mass than the pebble, which has a relatively low proportion of its molecules. When particles are dry and humidity is well below the dew point, a liquid meniscus or bridge forms in the gap between the particle and the adjacent surface, which adhere to each other through surface tension. This dissolve or otherwise modify the solubility of the contaminant in order for it to be more easily removed. If surface tension prevents water from coming between the surface and the contaminant to be removed, a cleaning solution should have several properties, including the ability to remove soil quickly and completely, to remove it with the minimum risk of redeposition on the substrate, to leave no residue, and to be non-toxic to personnel, to process materials, microorganisms. They represent particles in the size range 1 to 5 micrometers. And they're also minute packets of salts, chemicals including sodium, magnesium, carbon and others, which are hazardous in the microelectronics field. This, quite apart from their normal propensity for causing disease and inflammation. The factors to consider when deciding which disinfectant to use start with the type of microorganisms to be killed. Then, will the disinfectant be residue-free? Will it be non-tainted? Many, as we have seen earlier, are not effective against bacterial spores, whose reproductive cells may lie dormant for years, long after the apparent death. Because the living cells inside the clump are protected by the dead microorganisms on the outside. Hard water can also diminish a disinfectant's efficacy. And bacteria and fungi can adhere to surfaces, forming biofilms which alter the organism cell's surface properties, making them more difficult to remove and kill.